Here we are looking at 3.1, which is derivative of logarithms. So before we actually kind of get into like all these derivatives and things like that, let's go ahead and recap some of these properties that we've learned in some of our previous classes. So the first one is the product property with logarithms. And anytime you have a log with some base b of something plus another log with the same exact base of something, you can instead of adding these two logs, you can actually go ahead and do then the product of that, of a single log. So this would come out to be the log of the same base b of m times n. So notice it's just now one log, but those m and n values are being multiplied together. So a quick example of that would be, notice the log both have the same exact base. We are adding here, so essentially we can put that under one log with that same base 2 and multiply the 5 times the 4. And when you're all done, you would end up then with the log base 2 of 20. Now the quotient, pretty similar to the product. The only difference is that instead of adding, we are subtracting these two logs. And anytime you see that with the same base, you would actually then have one log with that base b, with the first log is going to be your numerator, so m, and then your second log that's being subtracted from your first log is going to be on the bottom, so that's your denominator. So an example of this would be, notice we are subtracting two logs with the exact same base. We can write that then as one log with that same base 4. And then the first guy is our numerator, so 10. The bottom guy would be our second piece, so 2. And so now we have this single log base 4 of 10 divided by 2, which just comes out to be the log base 4 of 5. For the power one, pretty much just says that if you have this kind of number or constant in front of our log, we can go ahead then apply it as the exponent for our m value. So that thing is interchangeable. You can bring that up to the front, bring it back. That's known as your power property with logarithms. And so we still have that log base b of m, but now that exponent would be raised to that p power. So just a quick example, we see that -3 is being multiplied by this log. Anytime that there's not a number right here for that base, it's assumed that it is 10, because we work in a 10 base system, a base 10 system. And as a result, just kind of showing what that power property would look like, just bringing that coefficient in front over to our exponent position. So we would then have the log base 10 of 2 raised to the -3. And so these properties with logs are actually going to help us when we start to do some of our derivatives. So that's why it's kind of handy to know just some of these properties beforehand. Now when we're looking at example 1, we're asked to condense the following. So for A, we see that we have this number right in front of a log, or natural log in this case. And as a result, natural log still works the exact same way with the logs, those properties. So we can go ahead then and take this 3 and move it back here and pretend that it is its exponent. So we have the natural log of x raised to the 3rd power, again that's that power property kicking in, plus the natural log of 5. Right there we just did the power property. Haven't touched the plus sign in between yet. Now that we have a natural log and another natural log, they actually both have the same exact base. If it's not written there, it's assumed it's e, that base e. And so they do have that, in fact, that same base, so we can go ahead then and multiply using our product property with logarithms. So just putting it under one natural log, we have the natural log base e of 5x cubed, just because I like to have the numbers in front of like an x term. And now we have our single logarithm. We've actually gone ahead and condensed that logarithm. Pretty much just made it smaller. For b, kind of the same idea. Looks like we have a coefficient in front of this logarithm. So we're going to go ahead then and bring it as the exponent for that number. Looks like this one has one as well, so I'm doing the same thing. And I'm just going to go ahead and take the number, so this 1/2 for this last logarithm, just the 1/2, not the negative, just the 1/2, and throw that as its exponent for 4 as well. So when we do that, we have, again, just using the power property there, we have the log base 3 of 8 raised to the 2/3 plus the log base 3 of 10 squared minus, again, we didn't take the minus sign, log base 3 of 4 raised to the 1/2. And this can be simplified further. Really, when we are adding these two logarithms with the same base, we would be multiplying that. So then we have, let's go with red. We would have then the log base 3 of 8 raised to the 2/3 times 10 squared minus the log base 3 of 4 to the 1/2. Now that we are subtracting these like base logs, we have the log base 3 of 8 raised to the 2/3 times 10 squared. Anytime we are subtracting by the second log, we actually have that quotient property with logarithms, so we're going to be dividing that 4 raised to the 1/2. So right there, we've gone ahead and condensed this item. And when we want to go ahead and simplify this further, we would have the log base 3, 8 raised to the 2/3 just comes out to be 4. And then 10 squared is 100. On the bottom, 4 raised to the 1/2, that's just taking the square root of 4, so that just comes out to be 2. And so when you kind of simplify everything up, looks like our log with the base of 3 will be of 200. So there we've gone ahead and condensed it as much as possible. Again, though, that is example 1 from our 3.1 set of notes.